Okay, so hello guys. So due to the connectivity issues that we had last time, so I decided to record my lecture lang on the basic concepts on descriptive statistics. So for this particular topic, I will be teaching and showing to you what are the parameters that you need to look or you need to take note in order for you to interpret your data properly. So for this particular discussion, we will discuss or review the measurements of central tendency. We have the mean, median, and mode. Also, the measurements for dispersion. We have your ranges, variance, and standard deviation. We'll also discuss quartiles and percentiles, frequencies, and standard error of the mean. Okay, so let's first define what is descriptive statistics. So descriptive statistic is being defined as a summary of statistic that quantitatively describes or summarize features from collection of information. So guys, unlike other statistical analysis such as correlation, ANOVA, or chi-square, descriptive statistic actually does not need a decision. Okay, it will not help in deciding whether to reject or to accept the null hypothesis. Rather, the importance of descriptive statistics is on how the sample is distributed, the spread of the sample, and also if the sample is being distributed in a way that it will go or it will coincide with the normal distribution curve. Okay, so for descriptive statistics, we don't dwell anymore with manual computations because the SPSS will actually give the values, automatically give the values. But I just want to give emphasis on what are the parameters that you need to take note or you need to examine for you to be able to analyze and interpret the data based on the size of your data sample, the spread of the data sample, and the shape of your data sample. So you can actually take note or you can actually examine these qualities using descriptive statistics. Okay, so we have four major categories underlining this descriptive statistics. So first is we have the measurements of your central tendencies. So you have your mean, median, and mode. Also the measurements for dispersion or variability. So we have the variance. We also have the standard deviation, the relative position, and the relationship also between the sample population. So whether it is positive uh, relationship or negative relationship. So let's take up the measurements of central tendency. So the main purpose, okay, for getting or for computing for the measurements of central tendency is to find the best representative value of the population. Okay, so I think you're very familiar with the three M's or the three measurements of central tendency. So we have the mean, the median, and the mode. So the mean is being defined as the arithmetic average of all scores. So it's like you're getting the average, okay, of all your results or all of your numbers. Okay, you add and you divide, okay, to get the mean. Then you also have the median, the score above and below which 50% of all scores lie. So when in a data set, in a particular data set, we arrange the values, right? And the midpoint value or the value that is in the middle is actually the median. So no problem for odd values, okay, or odd numbers because we can actually detect the median. For even numbers, we need to get first the two median or midpoint values, and we have to get the average. Okay, so that is applicable for even a set of data or even set of numbers. And of course, when you talk about the mode, this is the most frequently occurring score. Okay, so the most frequent score to appear is considered to be the mode. So in the exam, unya guys, in our midterm exam, don't forget to review how to compute for the mean, how to get the median, and also how to distinguish the mode. Okay, so this will also be part of our midterm exam. Okay, the next parameter are the measures of dispersion. So this is actually very useful, guys, whenever you want to analyze how your data is spread, okay, throughout the population. So whether it is part, okay, or it's within the normal curve, or is it shifting to the left or shift to the right? Okay, so the parameters that is very, very useful to assess how your data is spread, how the data spreads, or the dispersion characteristic of your data. We have four measures actually. We have the range, the quartile deviation, the variance, and of course the standard deviation. But always remember, guys, the most commonly used parameter is the variance, and of course you have your standard deviation. Okay, so these are the two parameters, okay, that is very, very useful for measuring the dispersion of the data. Okay, so the first is we have the range. Range is said to be one of the easiest parameter to achieve or to compute. Just simply get the largest value or the largest number, and you just divide it by the smallest observation or the smallest number. So the answer of it will be the range. But the main disadvantage of the range is that it's very insensitive to variability. Another thing is you have your quartile deviation. So your quartile deviation is only useful if you are using the median value instead of the mean value. This is being defined as 1/2 the difference between the upper and lower quartiles in the distribution. Okay, but the most frequently used parameter in the assessment of the spread or the dispersion of the data is your variance. So always remember that the variance is the sum of the squared distances of the data value from the mean divided by the variance divisor. So ang major disadvantage lang for the variance is the difficulty in the interpretation due to the squared metric result or the squared metric unit that is used by the variance. So here is the formula, okay, of course, of your sample variance. So in the exam, there's no need to memorize the formula, okay, because we don't do manual computations anymore for the variance. But I just want you to remember that the variance is very useful, especially in the assessment of the spread of your data or the dispersion of the data. Then you also have another parameter that is very, very useful in the assessment of the dispersion of your data. You have your standard deviation. What sets apart of your standard deviation to your variance is that the standard deviation is easily interpreted. Okay, very easy to interpret the values for the standard deviation, and the values are being it's actually the square root. We can actually derive the standard deviation by getting the square root of the variance. It also measures the spread of set of observation. That is why in comparison to variance, we often use standard deviation more to assess how your data is spread. Okay, is it being spread is it being spread equally, or are there any inconsistencies on how your data is spread? Is it going to the left or is it going to the right? Okay, so standard deviation can be one of the parameter that is useful in assessment of dispersion. So after the measurements of the central tendency and after the measurements of the dispersion, next is the measurements for position. So we have three parameters under the measurements of position. We have the quartiles, we have the interquartile range, and of course we have the percentiles. Okay, so always remember, guys, that whenever you talk about percentile, this refers to the total 100 parts. Okay, but when you talk about quartiles, okay, this is now the subcomponent of or subparts of your percentile. So always remember that for a 100% for a percentile of 100, okay, we have four quartiles that can be derived, right? We have four quartiles. So each of the quartile is consists of 25%. Okay, so if you will sum up all 25, all the 425, that will sum up to 100s. And for the quartiles, we have three subcategories. We have quartile 1, quartile 2, and of course, quartile 3. Remember that the quartile 1 will separate your first and second quarters, okay, which is part of the percentile. Your quartile 2 will separate your second and third quarters, and your quartile 3 will separate your third and your fourth quartile or quarters. Then we also have the term here na interquartile range. We can actually get or we can compute for the interquartile range if we subtract or if we will get the difference between your quartile 3 value and your quartile 1 value. But the main use of assessment for your interquartile range is also part of the measurement of the spread of your data, but it is robust to extreme observation, or it can be affected, it can easily be affected if you have extreme values or outlier values. Okay, so let's go now to the parameter which is very useful in assessing the position of your data sample. So usually for normal distribution, okay, if we will graph or if we will present your sample, okay, within a normal distribution, usually the graph will appear bell, okay, or bell curve shape or pyramid shape ang graph. So whenever that your graph is being presented in this manner, it will tell you that the sample is being distributed equally within the population, and the values of your mean, median, and mode are equal with each other. Okay, so equal values of the three measurements of central tendency, which is for me, it's really rare, okay, very rare to happen or very seldom to happen. Now, there are also other inconsistencies on how your sample is being spread also across the graph. There are times that your sample or the graph of your sample is positioned or skewed to the left. Once your graph is skewed to the left, it indicates a negative relationship. But if your sample is skewed or it's being positioned in the right, it indicates a positive relationship. Okay, so one parameter, guys, that is very helpful when you want to detect the position or the degree and the direction of your of asymmetry for your sample population is the skewness value. So if you try to look at your SPSS, okay, or if you try to look at your output, okay, your sample output, part of the descriptive statistic table is your skewness value. So your skewness is very, very helpful to know whether your graph is positively skewed, negatively skewed, or equally distributed. So what are some instances that your graph or your sample is positively skewed? So when the mean is larger than the median, it means that your measurements, okay, is positive or it's positively skewed, meaning to say that the direction of the graph is shifted or it's positioned to the right. Okay, so it's shift to the right. So naa sa right, ang direction niya is going to the right. That is positively skewed. On the other hand, whenever we talk about negatively skewed, it means that the mean is smaller than the median. So whenever the cases are like this, the graph or the distribution is negatively skewed, meaning to say that the graph is going or it's shifted to the left. Okay, but for instances that the skewness value is zero, okay, zero skewness result or is zero skewness value will tell you that the sample is being distributed normally or equally in the graph. Okay, so for a normal sample or for a normal distribution, guys, it's diba bell curve ang shape niya. Okay, bell curve siya. So it's equally distributed, normal sample distribution. So you can only achieve that if the skewness value is zero. Okay, so in the other words, guys, so look at your skewness result. If your skewness value, okay, is greater or equal to +1, okay, if your skewness value is greater or equal to +1, it means that the graph is shifted to the right. Okay, but if your skewness value is lesser or equal to -1, it means that your sample or your graph is positioned or shifted to the left. Okay, so again ha, kung zero ang skewness, normal ang distribution. But if +1 or greater than +1 ang skewness, it's shifted to the right. So for -1, lesser than -1 value, that's shift to the left. Okay, so that is all for the skewness result. Then you also have another parameter that is useful in assessing the peakness or the height of your graph. So we have your kurtosis value. So your kurtosis measures the heaviness of the tails of the distribution. So usually, guys, in SPSS, if you have a kurtosis value of 0, it means that your sample is normally distributed. So usually, it appears to be platykurtic. Okay, so whenever guys, that your kurtosis value is equal to 0, you can describe your graph as or your curve as platykurtic or it's flat. Okay, so items are evenly distributed. Okay, and also kurtosis, okay, is positive, okay, as like your skewness na it has positive and negative result. For kurtosis, it is positive. The tails are heavier, okay, than the normal distribution. And if negative, the tails are lighter, okay, than for a normal distribution. Okay, so I have here our rules, guys, or the things that you need to remember when you are using the skewness and kurtosis in the assessment of the normal distribution. So again, guys, in SPSS, if the value of your skewness and kurtosis is 0, it means that your sample is normally distributed or it has a bell shape curve, okay, if 0. But for skewness, I've mentioned this, that if the value is greater than +1, okay, it means that the positioning of the graph is going through, or it's shifted to the right. But if the value is lower or lesser than -1, it means that the positioning of your graph, or the direction of the graph, is shifted to the left. On the other hand, for kurtosis, if the value is +1, or it's greater than +1, it means that the kurtosis, or the height of the graph, is too peak, or it's too high. Okay? On the other hand, if the kurtosis value is -1, okay, or lesser than -1, it means that the value is, or the height of the graph is too flat. Okay, so remember guys, for kurtosis, if more than or greater than +1, that's too peak. A value that is lesser or equal to -1, the graph is too flat. Okay, so you can use the skewness and the kurtosis values for the assessment of the direction and the height of your graph. So what you will do guys in your output is that you measure, or you identify the value of your skewness and kurtosis per variable. So you don't need to interpret it per gender, interpret it as a whole, but you need to do the interpretation per variable. So look at the skewness and the kurtosis values for each of the variable, and try to examine whether it's normally distributed. Is it shifted to the left or shifted to the right? Is it too peak or too flat? Okay, so you may now use the skewness and kurtosis value for that. Okay, so to help you to understand better, guys, para makasabot o maka-understand jud mo sa how to interpret skewness and kurtosis, I have here an example. So look at the values for your skewness, okay, and kurtosis. So this is in relation to the variable height in meters. So for skewness, the result is positive 255 or 0.255. So the first thing that you will do is examine for positive and negative signs. So for skewness, it's positive 0.255. So that will give you the idea na that the relationship, or the value, is positively skewed, or the skewness is positive. So once gani na positively skewed, the direction of the graph is going to the right. So for this particular example, well, because it's not closer to 1, right? Dili kayo siya closer to 1. So maybe the graph is starting to go to the right pa. It's not shifted pa jud sa right, but it's starting to go to the right when we want to plot this. Next is look at the kurtosis value. The first thing that we will notice is the presence of negative sign, di ba? Negative 0.867. So this will give you the indication na on the height of the graph, especially that negative 0.8 is actually lesser, right, than -1. Okay, so it will give you the idea that the height of the graph, or the peakness of the graph, is too flat. Okay, very flat or too flat. So you will be doing this, guys, with your other variables. So interpret the variables based on the skewness and the kurtosis nila. Okay, do the interpretation as the whole. No need for the separate interpretation for the gender. So I want you to assess the positioning of the graph. Is it positively skewed or negatively skewed? And also the height or the peakness of your graph. Is it too high or too flat? Okay, so please go to the next video for the part 2 of this discussion.